Alright guys, so this is going to be a short video on work and power. So we've talked about work and how it changes the energy of the system. And an extension of that would be, okay, work changes the energy of the system, but you can imagine that we could execute this change very slowly, or we could do it very rapidly. And so when we talk about the rate that work is being done, that's when we are talking about power. So the definition of power, probably the simplest definition, would be the work done over a given amount of time. Okay, so with our work equation, you can say, okay, this is going to be force times the distance times the cosine of theta, divided by the time, t, and you can also say that this then would be the force times the velocity, because velocity would be distance divided by time. And so if this is a constant velocity, this will be the power that was delivered. If it's not a constant velocity, let's say it's just the average velocity, it would have an average power delivered. So the rate that work is done, the would be power. The units of power, okay, so units of power, a joule per second, which is the SI units of work and time, corresponds to a watt, and we abbreviate a watt with W. Okay, you may have also heard another unit of power is horsepower. Okay, so horsepower, and this is kind of a weird one. I'm making it clear for historical reasons, because when we talk about car engines, we usually talk about like how many horsepower it is. But when we talk about almost anything else, we talk about watts or megawatts or gigawatts or whatever, right? So 1 horsepower is going to be equal to 746 watts. Okay, so that's the conversion between horsepower and watts. So yeah, I mean, that's pretty much all I have to say about power, guys. So make sure you get this definition down, and the units and all that. And we'll work some problems in class and kind of show how we can use this as we analyze changes in energy. All right, if you have any questions, let me know.